Yeah. Welcome. Today we are going to discuss about the assignment number 6 related to the dealing with materials data, collection, analysis, and interpretation. So, regarding the assignment number 6, it is to deal with sampling distribution and parametric estimation. So, let's go into that. Before going to discuss the problem, let's see what is central limit theorem. So the central limit theorem tells that if sampling distribution of the sum of or average tends to approximate a normal distribution, which means like as you increase the sample size, the mean of the distribution tends to a normal distribution. It can be whatever distribution. You can see here, right? It can be non if it is normal distribution with an increasing sample size, it will become more and more pronounced normal distribution. In case of uniform distribution, it tends towards normal distribution. If it is some skewed normal distribution, like a chi-square distribution, it also tends to the normal distribution. So even the random distribution also approximates to the normal distribution. Then this is the sample size. So in that case, so what we can define is like the sample mean is equal to population mean. So the sample mean population is generally normally distributed, and if sample size increases, the sample also tends to normal distribution. Hence, the sample mean is equal to population mean. Yeah. And one more thing is then the sample standard deviation can be related to the standard deviation of the population divided by square root of n. N is the number of samples. So when can we consider a distribution, or when can we approximate a distribution to be a normal? Like even the binomial also can be approximated to normal distribution in when the number of samples size is greater than 30, greater than or equal to 30. You can consider the even binomial distribution as the normal distribution. So this is the example problem. Here they have asked which of the following statement is correct for the central limit theorem. So the first thing is the sampling mean and the population mean is equal. Yes, it's correct. Then second option is sampling standard deviation and population standard deviation is equal. It's not correct. Sample size is large than the mean. Large, the mean of the sampling goes, or mean of the sampling follow the normal distribution approximation. Yes. So we can tell the 1 and 3 are correct. Because if sample size is large, the mean of the sampling follows the normal distribution. Yes. Standard deviation and population standard deviation is not equal. Like only when the sampling standard deviation is divided by when population standard deviation is divided by root n, then only the sample standard deviation is base max, divide the population deviation by square root of n, then only the second option will be. Otherwise, 1 and 3 not correct. So going to the second question. Okay. So rather than going to the first question, let me discuss the second question first. Then we'll go ahead with the first question. So here, a coffee vending machine dispenses a varying amount of coffee with mean of 100 ml and standard deviation of 10 ml. So suppose you have ordered 50 cups of this coffee. Find the mean of the coffee in each cup and standard deviation of the sample. Standard deviation of sample mean. Okay. Assume the individual dispenses of independent. So basically, the dispensers are independent, and it's right the given data. So this uh, so this population mean and population standard deviation was equal. And then So we are taking 50 coffee, or we are ordering 50 coffee cups. Means like we are taking a sample of 50, and mean of each coffee, find the mean amount of each coffee in each cup and standard deviation of the sample mean. So first they are asking the mean. So as we know, population mean is equal to sample mean. So that can also be written as 100. That's what the sample mean. Then you want to calculate the standard deviation of the sample, then sigma by root, nothing but n divided by 7 divided by root n is, so it is 10 divided by 5 root 2, which is root 1.414. So standard deviation is 1.414. Standard. So the correct answer for this one is yeah, third option. So going to the first question. So actually, because this is like a derivative of the second question. So by the order of proceeding, I prefer the second question first and then first question at the second. So in this question, an electronics company manufactures some capacitor. Assume the capacitance follows normal distribution. With mean capacitance of 100 microfarad and standard deviation of 10 with 10 standard deviation of 10 microfarad. So if random sample of size 25 is collected from the whole lot, which means like sample size is 25, and population, yeah, the population mean, this is not sample mean, this population mean is population minus 100 microfarad. The standard deviation, population standard deviation is 10 microfarad. So, according to the central limit theorem, population mean is equal to sample mean. We have seen now. So, and population standard deviation is standard deviation of the, sorry, sample standard deviation is equal to population standard deviation. Sorry for my handwriting. Population standard deviation divided by square root of lot of mistakes in which never done. Population standard deviation. So what they are asking is they find the probability that the average capacitance X bar of the sample is less than 95 microfarad. Okay. So what we want to find is probability of X less than, sorry, probability of X bar being 95 and that was the mean. This is what their preference. So what we can do is like we can standardize this using the variable standard normal variate. So standard normal variate is that is equal to X bar minus mu by with square 1 by sigma sum. So in this case, Now we have to find standard normal variate of what is x bar. X bar is 95 minus 100 divided by sample. What is sample value? Sorry, I have found another question. The sample value is yes, 10 divided by root of 25. As we know, sigma sample is equal to population by volume or the diameter. So here left side is minus 5 divided by 2, 2 point, minus 2 point. So for minus 2.5, okay, this is the standard normal variate table. Here how you have to compare is like if you get 2.52 means you have to go to minus 2, sorry, minus 2.52 means you have to go to minus 2.5. In that, if it is minus 2.52 means just we have to go to the 0.02 value and you have to take this value. But here luckily we are just ending up with minus 2.5, which means like standard normal variate value is 0. So this is the problem. Yeah. The Z, sorry, the Z value is minus 2.5. So now probability of Z is equivalent to this because we have calculated Z value. So probability of Z is given by this table, standard normal variate table. For if P of Z is equal to minus 2.5, value is 0.0066. So the answer is first A. Hope you all understood how to use the standard normal variate table. First, we have to find the standard normal variate equivalent to this x bar less than 100. Then we have to estimate this standard normal variate value z. Then we have to compare the equivalent probability value of the standard normal variate in this using the standard normal variate table, which is here 0.0062. So this is how we have to proceed. So moving ahead to the third question, they're asking let x1, x2, x3 and xn be the sample from a population with mean mu and variance sigma square. If sample variance is s square, then expected value of the sample variance is equal to sigma square. See, derivation is that we can attach the derivation in the last part of this discussion because it's little time consuming for me. So let's discuss later part of this live session. Yes. Going to the fourth question. Suppose the height of individuals in the population of a particular state in India have mean of 167 centimeter and standard deviation of 27 centimeter. If the 36 individuals are selected randomly, probability that height will lie in between 163 to 170 centimeters. So before whatever we have dealt with is like a um, uh, it's like finding for one particular variable. Which means like if this is a normal distribution table, we'll be finding at one point and we'll with whatever value follow within that we take the probability of that one. Here they are defining an interval within which we have to find the probability. So how to find it we will discuss now. So the given data is like the population mean is 167 centimeters, and the population standard deviation is 27 centimeters. The number of people chosen or the sample size is 36. So based on this, we can find the sample mean and sample standard deviation. So after finding it, we have to find the z-score for the given values. Just 163 centimeter and 170. So what is the average? Average is 167. So the first value minus sorry, um, sample size is n 27 divided by divided by. I'm taking this numerator 27. That's 24 by 24. So we are going to find the values in probability value between these two standard normal varying. So okay, now we have found this Z1. Z1 is to calculate along with me. It's 24 divided by 27, 0.89. Similarly, let's go for Z2, sorry, X2 is given by 70 minus 167 divided by 27 and 30. This is again 3 by 3 into 6 by 27. And this is minus 0.8. The sign is also important because that gives the value before the main or after the main. 0.67. So 18 by 27, 0.67. Now we have to find the vector value for um, uh, so what is the problem? For that, it's probably uh, limited with the 0.67. Right? So if you're negative, the channel is that value based on the check the values are little lower than expected. We can check the values once. This one not on Peter. It's correct. Just I have to plug the values here. Probability of Z less than 0.67. So for 0.67, the Z score value is 0.7486, and for minus 0.89 is 0.5619. Functional factor is lesser than this because in the normal distribution plot, we are finding from left to left. So we are finding for Z1, so here is Z2, and then for Z1, and we are subtracting the infinity value there. So it is Z2 minus Z1. So that is what we are going to. So values are like 0.6 minus 1.461. So let's calculate the difference. It's, sorry, 18.8 something I'm getting approximately. So let's check with this answer. Okay, sorry, mistake here is for 0.89, it is 0.1867. Given the answer instead of that. So, point 1%. So, let us check the answer. That is, it's not matching with the given answer. Let me cross check it once. These for values. It's coming around 0.186 only. That's correct. And then, so with this, what answer I am getting is 0.5619 percentage. It's the answer which I'm getting, but the option is not there anymore. But the way to proceed is the same. That's how we have proceeded. Since the number of integers selected is more than 30, it follows normal distribution. when we have estimated the sample mean from the population mean and sample standard deviation from population standard deviation, and we have find the z-score value for x bar, x1 bar, and which is 163, and then we have found the z-score value for the x2 bar, which is 170, and we have subtracted the z-score to which we have found the probabilities of the respective z-score, and we have subtracted it. Sign was wrong or what we said. I think like whatever way we have proceeded is correct. Let me check the answer with the respective uh, NPTLP, and I will let you know. Moving on to the fifth question. Um, so fifth question. Lower related. Yeah. So the question is the concentration of the reactant influences the strength of the polymer. And when high concentration is used, the strength is 60 MPa. And when low concentration is used, the strength is 55 MPa. The standard deviation of the strength is 4 MPa, regardless of the concentration, which means like sigma x high equal sigma x low is equal to 4. I mean, sample standard deviation is short term. Okay. So if two random samples are taken, the size of the sample scale, they're asking what is the probability of xi plus I minus x low greater than or equal to. So unlike before, where in first question we have found the uh, we have found the probability value for minus infinity, just like for a point variable, 1 point, and then we have defined it. We have found the probability for a interval, just like from 163 to 170. That is high. Then now, if you see, we are finding the probability the probability for the difference in the sample mean. So that is like here sample mean for one polymer which is high strength is 60 MPa and with the low strength is 55 MPa. So let's proceed. Like how to solve this, we will discuss it. So first we have to find. We will assume it like a single variable. This like difference. Okay. Mean of the difference. Because here also we are going to find the z score and proceed because we have no other group. So difference is given by um, I. Since both are normally distributed, that is the assumption. So we can do this subtract arithmetic operation here. 69 to 12 is equal to. Then this, we have to find the z square, we need to know the two parameters, which is mu and standard deviation. So for standard deviation difference is given to square root of sigma 1 square and sigma 2 square and so here sigma 1 square, sigma 1 and sigma 2 both are same. 4 square plus 16 plus 4 is like 32 plus 10 root 50. Okay. So sigma difference is root 2. So now we just have to find the z value of this. Just like less than or equal to. So first we will find less than or equal to because that is possible because like as you know minus infinity to a particular z value it's possible and it is easy to find rather than from. So what we generally do is like we will first find this and we will subtract it with 1. So the same thing we are going to do. Z less than or equal to 2 given by 2 minus mu difference divided by mu difference. 2 minus mu difference is 5. Then sigma difference is root 2 minus 3 by root 2. This is nothing but almost value minus 2.12. So now we have got this z value equal to minus 2.2. And but the question is not less than or equal to 2. We have to find the x high minus x low greater than or equal to 2. So p of that greater than or equal to 2 is given by that one. So we'll first find p of that less than or equal to 2. 2.12. For that, first we look in the 2.14 for minus 2.14 minus 2.1 2. So it is 0.170. So 0.017. So it is approximately 0.98. So that is the p of x high minus x low greater than or equal to 3. So going after the question, so we have got the option HTTP. Well, sixth question. Sixth question is about at x1, x2, x3, and full x and be the random sample from normal population with mean mu and variance sigma square. Then sample variance is distributed as okay. So as we know, for a random sample which follows the normal distribution, then sample mean is equal to the population mean, and sample variance is equal to sample variance is equal to population variance divided by root n. So why that root n, all those things is to normalize that, which means like it is actually not following the normal distribution. If it has followed the normal distribution, then we would have directly told the variance of normal distribution is equal to uh, so variance of the sample is equal to variance of the population. But we didn't tell because the variance is skewed function. Generally, the variance won't be like a symmetric function as like we are seeing the mean value, sample mean value. So hence, we approximate it to the chi-square function, chi-square distribution, which follows, which shows this skewness in their profile, and they found the best fit for this sample variance. Hence, the sample variance is distributed as chi-square distribution with n minus 1 degrees of freedom. Here, like chi-square distribution is not symmetric, hence an additional parameter, like which is this the degree of freedom, which has to be uh, given, and chi-square distribution can be given by uh, sample size minus 1 into s squared by sigma square. Yes. So this is the answer. Going to the seventh question. Consider an independent Bernoulli trial with probability of success equal to p. What is the maximum likelihood estimator of p? So to find the maximum likelihood estimator, to estimate the maximum possible um, occurrence of this or success of p, what you have to do is like first we will define the probability loss function for the Bernoulli trial. This is a small derivation which I'm going to discuss now. So it may keep it very simple. So for Bernoulli trial, this is given by p. There are only two possible outcomes. Success is given by p. Failure is given by 1 minus. So let's say x is the number of success in n trial. Find the maximum likelihood of p, uh, which is by p of x p of max. So again, this one arrived. This is another derivation. Okay, let me go through it. So as we know, the probability mass function. Um, so the probability mass function of the Bernoulli trial is given by p of x is equal to x is equal to 3 power x into 1 minus 3 power 1, 1 minus x. So n of p, you just have to consider all the trials. X1 is equal to x1 into p of x2 is equal to x2. Plus the dot, the xn is equal to x2. We'll just keep on going. We can simplify this by L of P equal to um, x1 to P of minus x1, P of x2, and P of x2, P of x2, P of xn, to 1 minus P of. So this can be written in short like this is repetitive, and as we all know, for Bernoulli trial, for it's an independent random variable, means it happens independently each trial, and probability of success, like throwing a coin, or the probability of getting a headless coin, which is going to be remain same. It is not going to change with the number of trials. So P is constant, and with n trials also you are going to have the same P value. So P also returns P of x. So this is how we have got the L of P. Now to get the maximum value of P, what we are going to do? We are going to use very simple uh, case. B of LP divided by D, where we end up in x in power minus 1 power minus x e power x into 1 minus x into minus 1 minus whole power n minus x minus 1. So we can simplify this by taking p of x minus 2 x minus p out. Then we can see we can have only x minus p of n minus x equal to 0. As we are equating it to 0 for final maximum value. So with this, we equate it to 0. P cannot be 0 because as per the probability, then it is like it's no result. But this width can be 0. So hence we will substitute this x minus p of n minus x is equal to 0. Then x minus n, the x is equal to t into the n minus x. Then e is equal to x by n minus x. So considering the value of n, x is very, very small. Hence we can write like just x by n. So e is equal to x by is the maximum likelihood estimator of p. So we just have to write it like x I by n summation equal to 1. The same form can be written like this. So whatever matches this, yeah, is the correct answer. Into the eighth question, the following data of the melting point of lead is calculated using the molecular dynamics simulation from 24 simulations using different random seed. So they used the 24 random seeds starting from 330 to 340. Assuming that the melting point data follows a normal distribution, whose mean as true melting point of the lead. Calculate 95% confidence interval for the melting point data. They're asking 95% confidence interval for the melting point data. So how to find this? So we will discuss now. So first, let's find it. Here, n is less than 0, hence we can use either t distribution or like uh, we can also try with the normal distribution as well. Um, First, we have to find the we don't know the population mean, population variance. So we have to find the population mean first, sorry, sample mean directly from the given data. So sample mean is nothing but x bar is equal to 1 by n into summation equal to 1 to n. So I have already calculated these values. The average mean which I got is 334. Uh, yeah, 334 which I got. And then we have to find sample standard deviation. Sample standard deviation is given by S is equal to square root of this. It's a variance, right? It's variance formula, so we are taking square root by n minus 1 summation of x equal to 1 n xi minus x whole square. So if I already calculated this because this will take a lot of time. So the answer which I have got is 6.95. So till now we didn't have any kind of confusion. So now the major confusion is like which way we have to proceed. Should I use the T table or should I use the standard normal variate table, set table to find the values? So here we have a guidance for this. Like if you know the population standard deviation, then you can go with the Z table provided again if the sample base is more than 30, you can use the Z table. If this population standard deviation is not known, we can directly go to the T table. So that is what here we are going to do. We don't know the population standard deviation, so we are directly going into the T table. So for that, first we have to find a critical value. So critical value can be defined from the confidence interval. Confidence 95%. For 95%, if we go and check what is the z value for the critical value, it is 1.960. So plug in this 1.960. Then, as per the t distribution, the confidence interval range is given by mu plus or minus e. E is the margin of error. So E is again given by critical value to sigma sample by root n. Here critical value is 1.960 into just I'm trying to find the margin of error into what is the standard deviation which we have found. Sample standard deviation 6.95. So 95 divided by root of the sample size is 24. Which I have already calculated is 2.78, the margin of error. So the range is 334 plus 2.78 to 334, sorry, minus 3.7, 334 plus 2.7. So 2 given by, just a minute, 336.78 for bond value. Then 331 to slower bond value. So this is the confidence interval. The answer is correct. This is how we have to use the T table. So moving forward to the ninth question. The number of machine failure results in breakdown of production line in a company for 10 randomly chosen days. So 10 top date is 10, and they have taken the number of machine failure which can lead to the breakdown of the production line. Because like even if one machine that is not functioning, the line is line constitutes of it's like a parallel sequential process. Like from one line, the completed product is sent to the next line. Hence, if one line leads into the breakdown, the next line also doesn't have parts to proceed with the subsequent production. So hence, in this case, they are asking estimate the proportion of breakdown of production line due to two or less machine failure. Assume the data follows Poisson distribution. So the yeah, and they have given the maximum likelihood estimate of Poisson parameter is so the one which we have derived for the Bernoulli trial. They have already given here. So just a minute. Okay. So here first, what we have to do is like we have to find the maximum likelihood estimator, and from that only we have to find the proportion. So for that, We have got n value. So let's find the maximum absolute estimate is equal to summation of all. So summation of xi results in 25 divided by number of values 10. So it's 2.5. So maximum likelihood estimator for the Poisson parameter is 2.5, and now using that, what we have to find is uh, probability of failure being x less than or equal to 2. So lambda is 2.5. We know the probability function of Poisson distribution is given by e power minus lambda into lambda power x by x factorial. So p of x less than or equal to 2 is given by now its probability vector equal to 0, now its probability of x is equal to 1 plus probability of x is equal to 2. So now probability of x is equal to 0, e power minus 2.5 into lambda is 0.5 power 0 by 0 factorial plus that becomes 2.5 into 2.5 power 1 by 1 factorial plus e power minus 2.5 into 2.5 whole power 2 divided by 2 factorial. So if we estimate the values, this will be like e power minus 2.5 plus 2.5 into e power minus 2.5 plus 0.5 square by 2 into e power minus 2.5. So if you find the value for these all the three things for this 0.082 plus for 2.85 into e power minus 2.5, which is 0.21 plus for e power minus 2.5 into 2.5 square by 2, the value is 0.246. Hence, if we add all the three, it will end up into 0.54 something approximately. So, just matching the closest value here, which is the A value. Yes. So the answer for the ninth one is A. So coming to the 10th question, last and final question, the interval estimator of the sample variance from a normal distribution would be based on interval estimator of sample variance from a normal distribution. If you have any doubts now, you can ask, can answer. So the last and final question is the 10th question, which involves the question is like interval estimator of sample variance from a normal distribution would be based on what? So the options are like normal distribution, t distribution, f distribution, and chi-square distribution. We know normal distribution, t distribution, and f distribution. So t is for T is also called as the student T distribution for hypothesis testing. Then normal distribution is already been discussed more in detail. So F distribution is like not in our context. It is related to the regression analysis. We are not going to discuss in detail here. So anyway, like chi-square distribution we have discussed before, stating that this sample variance follows sample mean is equal to the population mean, and a sample variance follows the chi-square distribution. That is what we have seen before. Here also the trend remains the same. Here, because interval estimator of sample variance for normal distribution will be based on chi-square distribution. So answer is chi-square. Let me explain from the basic. Like for that, like we have seen so far, like what is the point estimators. For example, like if we want to question something, like on an average, like how much time a person spends in a phone. For that, if we are expecting a one answer like 3 hours, 2 hours, 4 hours, then it falls in the category of a point estimator. Whereas if you are asking like or like if you are interpreting a data like on an average, people spend between 2 to 4 hours with a 98% confidence interval, means it has more data, like it has more information which discusses clearly, because like in the other case it is may or may not, but in this case 95% confidence that this can happen or this is happening. So yeah, for that we use this chi-square distribution where we determine the intervals based on this formula. It is the interval will be between n minus 1 of x s square, where n is the degree of freedom, s is the sample variance, and chi of alpha by 2 comma n minus 1, and n minus 1 means this is the lower critical value, then upper critical value is n minus 1 of s square divided by chi of 1 minus alpha by 2 to n minus 1 means comma n minus 1. So substituting our values here, like in our problems, will get us the confidence intervals for normal distribution. Same thing can also be recreated in the R language, where you can see the set seed. Okay, let's see how this program is constructed. First is like feeding this normal data. For that, first we need to say what is the random numbers that have to be generated. For that, like if I just give data R norm 20 mean 10 and SD2 means it will generate 20 random numbers. That is what it knows, right? But if I give some seed like 1, 2, 3 means every time whenever I use this seed 1, 2, 3, it will generate the same random numbers for the comparison. Okay. So it will be useful for the better visualization and comparison rather than going with every time new random variables. So here data is the 20 normal value variables, 20 normal values with mean 10 and standard deviation 2 is fed to the data, and then the length of data is fed to the n, because like we have to determine degree of freedom in the data stages. Then sample variance is given by variance of the data. It's very straightforward. Like if I want to calculate the mean of the mean of the sample is equal to mean of data. Like that only will generally calculate. Then alpha of 0.05 tells us that we are estimating for the 95% confidence interval. So the degree of freedom is determined by df is n minus 1. Because if you know the n minus 1 character variables characteristics, then the other one or that last characteristic also can be easily determined from this. So that is the basic idea of it. Then okay, then we will find the critical values. For that lower circuit, we are feeding this q chi square of 1 minus alpha by 2 comma df. So here q chi square is for quantile, like it will only give the particular quantile whatever we are requesting for. It is 1 minus alpha by 2 here, and upper circuit is chi square into 1 alpha by 2 comma the degree of freedom. So here it is two values parameter. Parameters whatever we have to give is two, like that is alpha and degree of freedom. So now critical values are functions are there defined. Then we are giving confidence interval for the variance, like lower Ci is given by df into sample variance divided by lower critical value. Then up means this lower critical and upper critical values are just this chi of alpha of 1 minus alpha by 2 and chi of alpha by 2. That's all. That's nothing else. Then, as per that discussion, like we are just feeding the values like degree of freedom into sample variance divided by lower critical values. For it's upper critical values. Then just we are using the concatenate command. Like concatenate command facilitated us to um, bring both the text as well as the data together. Like in C plus plus we use the cout command, right? Like similarly we use uh, concatenate command where sample variant whatever they are within the double brackets are printed as it is, like sample variance and 90% confidence interval for variance, all those things. But remaining things whatever we define there, like sample variance or lower CA and upper CA, all those things, the values will be, yeah, values will be fed, or the value corresponding values will be printed. So I hope till now things will be clear. If you have any doubt, you can ask. This is my mail ID. So if you get some doubts or like if you have some query, you can directly mail to this. I'm happy to answer. Thank you.